All right, let's go ahead and get started with the base 10 numbering system. Why is 345 345? Why do we even say that? Why do we even care? Well, it's because it's based on a base 10 numbering system. A decimal notation is what we use. And deci is the prefix meaning 10. Why is it 10? Because no matter what number you come up with mathematically, you are only using 10 numbers, 10 digits, okay? And thanks to the ancient peoples, 0 is the first digit. All right, so I want you guys to get a grasp of that because everything in IT starts with a 0. If we count from any type of number, we start with 0 always. 1 is not the first number anymore. So let me prove it to you. First number 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Because we started with 0, okay, then we have 10 digits from 0 to 9. So anytime you start with 10, anytime you start with 0, whatever your last number is, the total amount of digits is going to be -1 because you started with 0. That happens a lot in IT, okay? All right? 10 digits. I can come up with a large number. 2,563,923. I'm still only using these 10 digits. That's the base 10 numbering system. Let's break it down even more. I'll start with the number 345. This number 345 is just not because you were taught it's 345. We have what's called place value. Now pay close attention to this because this is going to be important as we transition into the base 2 numbering system. We have the ones place, the tens place, and the hundreds place. Okay, I know what you're thinking. Like, this is so basic, and it is. But it's so very important. It's a great foundation. This 5 is a 1 position here because it actually represents 10 to the 0. Who can tell me what any number to the 0th power equals? If you said 1, you're absolutely correct. I don't care if I have 1 million. If it's to the 0th power, then the answer is going to be 1. So I actually have here 10 to the 0th times whatever number is in that place. So the number doesn't have the value. It is the place that gives the number its power. Okay? So we have 10 to the 0th power times 5 plus 4 is just not 4 for 45. It's in the 10th place. And it actually means, who can tell me what my power would be? You got it. The first power. So it'll be 10 to the first power times 4. Okay? Got that? Plus our last place value, our last placement is the hundredths place. And I know you know what that power would represent in our decimal notation, in our base 10 numbering system. That would be 10 squared, or 10 to the 2nd power. And it's going to be times 3. And this is going to equal, if we bring it all over here, I'll use a separate color, I'll use my black. It's going to be, if we bring it together, we have 5 plus 40 plus 10 to the 2nd is 100 times 3, 300. Which gives us 3 hundredths, 4 tens, 5 ones. Now, for all my parents out there, if you have children, this is exactly how they're teaching their math today, which is exactly the way I started out teaching my children math when it came to place value and learning multiple placements of numbers, or numbers with multiple digits, large numbers. And I'm happy about that. I know we had some confusion. Some people were not so happy, but if you can understand this, you can help your kids with their homework a lot better, okay? So this is our base 10 numbering system, all right? If you have any questions, just send an email to ganttechteach@gmail.com. That's GANTTECHTEACH, no spaces, @gmail.com, okay? That's our base 10 numbering system. All right? Let's take this information and the idea of place value and whatever my base is. See, base 10. If you remember in exponents and powers, this is your base and this is your exponent or your power. Okay, that's the exponent. This is the base here. So if you remember in math class, base 10 numbering system, we're going to keep this similar idea and we're going to take it to the also famous base 2 numbering system. I'll be right back, okay?